Now we're at the end of Unit 2, and you're going to be taking the Unit 2 test Part 1 and 2, and I just thought I would put together a little review for you so you could be better prepared for the test. Before we get too far into the slides, I wanted to show you this right quick. I went through the test, Part 1 and Part 2, and Part 1, these are some topics that you're going to see on that test. Know how to write a conditional, a converse, inverse, contrapositive, and biconditionals. Know the symbols used for conditional statements, and that would be P is the hypothesis, Q is the conclusion, the arrow means implies, the tilde mark means not. Be able to look at and analyze Euler diagrams. Define and understand indirect proofs, which means that you're going to contradict what you want to prove. And then define and perform algebraic calculation for the following angle pairs. Adjacent angles, complementary angles, supplementary angles, vertical angles. Be able to recognize the following properties of equality and congruence and algebraic properties of equality. Know the difference between a theorem and a postulate. And then on the Unit 2 part test, look at what I'm telling you here. There is 4 questions on the test, and this is what the 4 questions are about. Determine reasons in a proof in which the statements have been completed for you. Have your list of postulates, theorems, and properties handy, as well as your textbook with definitions. Determine a valid definition, which means be able to prove or disprove a definition by writing a converse, biconditional, and using a Euler diagram. Be able to define inductive and deductive reasoning, explain their uses in mathematics, and how they help develop and prove theorems. And then write a conditional, converse, inverse, and contrapositive of a statement, and determine which ones are true or false. And the true and false part, you're going to support this with a truth table and one property. And this is all information that we will be covering in the slides. I just want to kind of give you a breakdown of exactly what I saw on the test. Okay, let's go ahead and get started with this review. Methods of proof and logic. Let me get my pointer. Y'all know I love my pointer. Okay, proofs use deductive reasoning. Okay, remember we said that a lot. A type of reasoning that uses previously proven or accepted properties to reach conclusions. You have the law of syllogism. Remember, A implies B, B implies C, therefore A implies C. You have your law of attachment that says A implies B. If A is true, therefore B is true. A conclusion must follow logically. Valid arguments follow specific patterns such as the law of detachment and the law of syllogism. Elements of a 2-column proof. A proof shown in 2 columns, the first column of which shows the steps and the second column of which shows the basics for each step. Conditional statements. A statement in the form if P, then Q, in which the hypothesis, the if part, implies the conclusion, the then part. You have your converses, which is a conditional statement that switches the hypothesis and conclusion of the original conditional statement. An inverse is a conditional statement that negates both the hypothesis and the conclusion of the original conditional statement. A conditional contrapositives, I almost forgot to say that. A conditional statement that switches and negates the hypothesis and the conclusion of the original conditional statement. And then you've got conjunctions and disjunctions. Remember, a compound conjunction uses the word and is true if and only if both statements are true. A disjunction is a compound statement that uses or and is false only when both statements are false. And then we have inclusive and exclusive. Inclusive, a disjunction that includes the case where both P and Q are true. And exclusive is a disjunction that excludes the case where both P and Q are true. Properties of equality. Plain old common sense written down in the language of mathematics. Reflexive and symmetrical properties. Reflexive is like looking in a mirror, nothing changes. And symmetric have terms trade place, but they still have the same values. For instance, A plus B equals B plus A. See how A and B switch places, but they're still going to have the same values. If you had A plus B equals A plus B, then that would be reflexive. You have a transitive property. This transfer equivalence or congruence across a common expression. Suppose that Alex is the same age as Sam and Sam is the same age as Jamie. Therefore, Alex is the same age as Jamie. That's transitive. And then setting up a proof, you need a theorem, you need a figure, you need the given, and you need to show what you're going to prove. Number your steps, and when it says mark it up, that means mark up the figure. And we got conditional statements written in the if-then form. If an animal is a cat, then it doesn't really have 9 lives. The converse, you're going to flip the hypothesis and conclusion where Q implies P. Says if an animal does not really have 9 lives, then it is a cat. See how all we did was flip them. The inverse, you got to negate the hypothesis and conclusion, and see how the symbols are written? Not P implies not Q. If an animal is not a cat, then it really has 9 lives. They kind of messed that one up. And a contrapositive, you're going to flip and negate. See how it says not Q implies not P? So I'm flipping it. If an animal really has 9 lives, then it is not a cat. Sounds like they messed that one up too, because to me, cats always have 9 lives. Okay, here's a Euler diagram. Remember, you got a small circle right here that represents the hypothesis. You got the big circle that represents the conclusion. So here we got P implies Q. If I study for the test, then I will pass it. So here's your hypothesis. I study for the test. Here's your conclusion. I will pass it. Here's some truth tables. Remember, your conditional will always look just like this table right here. Your converse will always look like this one. Inverse will always look like this table. Contrapositive will always look like this table. Okay, and notice when you negate things, it makes this tables a little larger. Also remember that these first 2 columns are always the same. TTFF and TFTF. I don't know, I feel like Tigger when I say that. TTFF and TFTF. Okay, let's look at angle pairs. You need to know their measures and how to calculate missing angle measures. Here you have some supplementary angles. They're going to add up to 180. There should be the word B in there. Can be non-adjacent or adjacent. They can be right next to each other, or they can be separated like in this picture. But they have to add up to 180. Then you have complementary angles. They're going to add up to 90 degrees, and they too can be adjacent or non-adjacent. Again, they can be right next door to each other, or they can be separate like this one right here. But they're always going to add up to 90 degrees. And then you have a linear pair. A linear pair always adds up to 180 degrees, which makes them supplementary. And they are always right next door to each other. Always. On a straight line. More about angle pairs. You've got vertical angles. Here's the definition. There's what you got to remember. Always congruent. Vertical angles are always congruent. Okay, angle pairs, calculating missing angle measures. The first one over here says, what's the measure of angle CFD? So you remember I like to go and find out where my angles are. Here's CFD. Looks like to me it's 150 degrees. It's already been given to us. Oh, I must have been going to write these in. I thought I already had the answer set. Okay, so CFD, I guess I got to get my pen. And I got to also put it in a color that's going to show up here. Could have swore I already had these up here. So let's say that's 150 degrees. And it's already typed in for us too, so we can see it. On this next one, we want to know what AFE is. So let me see. CFD is 150. Here's AFE. This little box right here, that tells us it's a 90-degree angle. So I'm just going to keep writing these in. I'm writing them in up here because my ink is in white and I can't write on that white with it. So I'm just going to keep writing them up there. So the measure of angle AFB, oh look, this one right here, AFB. I wonder what that one is. How would we figure that out? Well, we know that EFD, I'm gonna have to change color so I can write this in. We know that AFD is going to be 30 degrees. Oops. We know this one is 90. Since BFC is a vertical angle to EFD, I know it's 30 degrees. So 90 minus 30 is going to give me 60. Oh my goodness, I had to figure them all out just to figure out what AFB was. Oops, I guess y'all can't see me write with black ink up there. Let me write 60. Alright, does everybody see that? 90, 30, 60, 30. Because I know I'm going to have to write all this down again. Let's see, 90, 30, 30, and 60. And let me show you, since this right here is 90 degrees, that means this side is also 90 degrees. That's how I knew to take 90 minus 30 to give me 60. So let's write that down up there. I can't remember if this was the last angle or not. So that was 150. That was a 90. Both of those were given. AFB I had to figure out. EFD, I figured that one out because I took 180 because EFD and CFD are a linear pair. There, I put that. And up here, this was 90 minus 30. And then BFC, of course, was the vertical angle to EFD, so it too is 30 degrees. Alright, let's look at those properties of equality. We talked about them just a few slides earlier, but this goes into a little bit more detail. Properties of equality. You've got the addition property of equality, which says if A equals B, then A plus C equals B plus C. You got the subtraction property of equality, which is pretty much the same. If A equals B, then A minus C equals B minus C. The multiplication property of equality, if A equals B, then AC equals BC. And then the division property of equality, if A equals B and C cannot equal 0, then AC equals, A divided by C equals B divided by C. Okay? Notice how this is all of your operators. You got your addition, subtraction, multiplication, and division. And then, lastly, I think it's the last one, the substitution property of equality. If A equals B, then B can be substituted for A in any expression. So that means if A equals 2, then 2 can replace A in any expression. That was the last one. Okay, the equivalence properties of equality and congruence. You have the reflexive property of equality and congruence, which says A can equal A is congruent to A. You've got your symmetric property of congruence, and it says if A equals B, then B equals A. See how B switched places but kept the same value? And if A is congruent to B, then B is congruent to A. Then you've got your transitive property of equality and congruence. If A equals B and B equals C, then A also equals C. If A is congruent to B and B is congruent to C, then A is congruent to C. Remember, all these things are items that you can use in proofs. Talking about proofs, inductive and deductive reasoning. Now this is a question on your test, okay, on the part 2. What is the difference and how can they be used in proofs? Inductive reasoning is a type of reasoning that is based on observations of patterns and past events. You draw a general conclusion from specific observations, experiments, or measurements, and forms a conjecture which must be proven. Is not used in the process of a proof. And deductive is a type of reasoning that uses previously proven or accepted properties to reach conclusions. It helps you draw a specific conclusion from general observations, and it's used to prove conjectures. Once proven, they become theorems, which can be used to prove future conjectures. How do you do a proof? First, you draw the figure and you mark it up, okay? And it may have already been done for you, but sometimes you got to draw them yourself. List the given, statements, and conclusion. Okay, that's your 2 columns. You got your statements column and your reasons column. Mark the figure. Oh, I kind of said that up here when I said to draw it. According to what you conclude about it from the information that is given. And then write your steps carefully. This is going to be your statements and your reasons. Even the simplest ones. Some of the first steps are often the given statement, and the last step is the conclusion that is to be proven. And you got to fill in all the statements in between. And please, please, please review all of the vocabulary that we've been learning since Unit 1, because all the definitions can be used for your proofs. And we covered some of them, but not all of them. And good luck on the test. And don't worry about completing the attendance survey. We do that when we're in CC. We're not going to mess with that right now. You can't hardly see my black lines that are going through it. But I'm marking it out, so don't worry about that part. And like I said, good luck on the test, and thanks for listening.